Welcome to the video for the Unit 7 Extra Practice Worksheet. Number 1, we're trying to find the degree of the polynomial using the finite differences method. So, our first step is going to be to find the difference between the consecutive terms. So here, it's going down 6, then down 4, down 2, no change, up 2, and then up 4. So it's not a first degree polynomial because the first differences are not all the same. So we look at the second differences. Plus 2, plus 2, plus 2, plus 2, plus 2. So since the second differences are the same, the degree would be 2. It's not because this number is 2, but because they're all the same, the degree is 2. For number 2, we're going to write this quadratic that is currently in general form into vertex form. So recall that vertex form is y equals a times the quantity x minus h squared plus k. So to complete the square, we're going to look at the b, which is the coefficient of the x term, which is negative 6. Now, if we had a number in front of x squared other than 1, we do need to factor that out first. So we find b, which is 6. Half of 6 is negative 3. And if we square negative 3, we get positive 9. So we're going to need 9 to complete the square. So I have the x squared minus 6x, and I'm going to add 9 to complete the square. I still have this plus 7 here. And because I added 9 to the right side of the equation, to make things balance, I also need to subtract 9. So this part here makes up my square. And it's simply x minus 3 squared. This number here will always be that half of b part. 7 minus 9 is negative 2. So there's our answer in vertex form. For number 3, I mentioned this in class, but in case you didn't hear or forgot about it, I really wanted to make this a positive 56. Otherwise, this quadratic is not factorable. So if we use positive 56, then we're looking for two numbers that multiply to 56 and add up to negative 15. Since the two numbers multiply to a positive and add up to a negative, I know they're both negative. So I'm looking for a factor pair that multiplies to 56 and adds up to 15. Well, I know 56 and 1 isn't going to work. No. 3 doesn't even go into it. So I keep going until I find the two numbers that add up to 15. And I get 7 and 8. Now we said they both had to be negative, so the two numbers are negative 7 and negative 8. So, factored form would simply be x minus 7, x minus 8. Number 4, we want to write in general form. Well, here's general form. It's going to be y equals ax squared plus bx plus c. Notice that we don't have any parentheses for general form. So first, I'm going to rewrite this expression without the exponent. So I just wrote it as x plus 4 times x plus 4. Then I'm going to multiply. I'm going to choose to multiply the 3 times the x plus 4. If you wanted to multiply these first, that's fine. So 3 times x is 3x. 3 times 4 is 12. Then we can go ahead and FOIL this out. 3x times x is 3x squared. 3x times 4 is 12x. We get another 12x plus 48, and then we still have this minus 5. So combining like terms, we get y equals 3x squared plus, these combine to 24x plus 43. Okay, once again, we want to change this quadratic into general form. This one's actually a little easier because all we have to do is FOIL once and combine like terms. So 2x times x is 2x squared minus 16x plus 5x minus 40. So y equals 2x squared minus 11x minus 40. Okay, the backside. Now we're solving equations. So we want to solve by factoring. Notice we have 0 on one side of the equation. So now we can try to factor. So because a is equal to 1, we can go ahead and use the shortcut method. So we're looking for two numbers that multiply to negative 30 and add up to negative 7. Well, I know that 10 times 3 is 30. In order to make the sum equal to negative 7, the 10 would be negative. So I get negative 10 and positive 3. Factored, we'd get x minus 10 times x plus 3 equals 0. So once it's into factored form, we're going to set each factor equal to 0 and solve for x. So here we'd add 10 to both sides and get x equals 10. For this equation, we'd subtract 3 from both sides, and we get negative 3. So our solutions are 10 and negative 3. For number 7, since a is not equal to 1, we're going to go ahead and have to do the long method. So we find a times c. 2 times 30 is 60. And my b is 19. So what two numbers multiply to 60 and add up to 19? So if we try 60 divided by 2, we get 30. Well, that adds up to 32, those two factors. 3 and 20 add up to 23. Oh, look. 4 times 15 is 60, and 4 plus 15 is 19. So the numbers we're looking for are 4 and 15. So we're going to rewrite the middle term using these two numbers as our coefficients. And then we're going to factor by grouping. So the greatest common factor of 2x squared and 4x is 2x. In the parentheses, 2x squared divided by 2x is x, plus 4x divided by 2x is 2. Factoring out what we can out of 15x and 30, the greatest common factor is 15. 15x divided by 15 is x. 30 divided by 15 is 2. since these are the same, we can rewrite this as 2x plus 15 times the x plus 2 equals 0. And then we just set each factor equal to 0, find the solution to those two equations, and those will be our solutions to our original equation. So we get 2x equals negative 15. Divide both sides by 2. X is negative 7.5. Here, we subtract 2 from both sides, and we get negative 2. So x is negative 2. Okay, so solving an equation where you only have an x squared and no x is pretty easy. What we want to do is get the x squared term by itself. So first, I'm going to add 245 to both sides. And I get 5x squared equals 245. Then, to get x squared by itself, I'm going to divide both sides by 5. And we get x squared equals 49. So square root both sides. And we get the absolute value of x is equal to 7. So our solutions are going to be positive 7 and negative 7. For number 9, we're going to need to complete the square. Notice that a is 1, so I don't have to factor anything out. My b is negative 4. Half of b is negative 2. So half of b squared is 4. So when we are solving an equation using completing the square, we usually want to get the constant term over to the right side first, if it's not already there. And then we'll complete the square. We're going to do that by adding 4 to both sides of the equation. So we can rewrite the left side as x minus 2 squared. Remember that the b over 2 is that negative 2 in this problem, and that's the number that goes inside the parentheses with x, equals 3. So we'll go over here. We'll take the square root of both sides. And we get the absolute value of x minus 2 equals radical 3. At this point, if we could simplify radical 3, we would. But we can't simplify radical 3. Radical 3 is prime. So we can go ahead and separate into our two equations. X minus 2 equals radical 3, and x minus 2 equals negative radical 3. So for both these, we'd add 2 to both sides. And we get one answer of 2 plus radical 3. And the other solution is going to be 2 minus radical 3. Okay, in the last two problems, quadratic formula. The quadratic formula works if it's in general form, which number 10 is. So in this case, my a is 4, my b is 11, and my c is 5. Now, I will give you the quadratic formula for tomorrow's test, or today's test if you're listening to this Friday morning. You just need to know how to substitute and simplify. So the opposite of b is going to be negative 11 plus or minus. Then inside the radical, we get b squared, 11 squared, minus 4 times a, which is 4, times c, which is 5, all divided by 2 times 4. So inside the radical, I get 41. All over 8. Now, 41 is prime, so I can't simplify it. So my answers are going to be negative 11 plus radical 41 divided by 8, and negative 11 minus radical 41 divided by 8. Okay, last problem, not in standard form. So we'll fix that by subtracting 12x from both sides. We get x squared minus 12x plus 5 equals 0. So my a is 1, my b is negative 12, and my c is 5. Opposite of b, the opposite of negative 12 is positive 12. There's my b squared, minus my 4, my a, and my c. Okay, just a reminder, when you're squaring a negative number, put the negative number inside the parentheses and the exponent on the outside. And we get 124. Now, can we simplify the square root of 124? We know that it's even and it's bigger than 2, so it's not prime. So we go ahead and try a factor tree. That's 2 and 62. And 62 is 2 times 31. So we get a pair of 2's. So that's actually equal to 2 radical 31. Now, notice that all three of these numbers here have a common factor of 2. If you just want to write 12 plus 2 radical 31 over 4 and 12 minus 2 radical 31 over 4 is your answer, I'm going to be okay with that for this quiz or this test. But what I'd hope you'd realize is that since the top and bottom have common factors of 2, we'd reduce it. Excuse me about that. And those would be better ways to answer it. Thank you for taking the time to watch this video. Good luck on your test.